All right, welcome back to Inorganic TUTOR'S Institute. In today's lecture, we are basically going to continue with episode 4, right, where we look at De-Morgan's laws in algebra. So basically, it's still in sets, okay? Now, remember that we are still under the big umbrella, union and intersection of sets. Union and intersection of sets. So, before we begin, I want to give you a brief introduction before we start the whole process. So basically, when it comes to algebra, we often work with the combination of sets, all right? Where we talk about union, intersection, and complement, okay? Now, this guy here, De-Morgan's law, they describe how best, or they describe how the complement of a union, all right, how the complement of a union or an intersection, how the complement of a union or an intersection can be expressed in a simpler and equivalent form, in a simpler and equivalent form. So the underlying word is simpler and equivalent. Simpler and equivalent. Now, these laws are fundamental because, one, they will help us to rewrite, simplify, and prove identities involving sets. And help us prove identities involving sets. So basically, this is an overview about the De-Morgan's law. So before we begin, I want to give you some preliminaries. I want us to recall some basic things that we might have forgotten, right? So before we begin the whole process, I want us to recall some basic things in De-Morgan's law before we begin the whole process. So first of all, 1, if you see U, it means universal set. 2, if you see A cap or A prime, it means complement of set A elements. Complement of set A elements. All right. If you see A cap or A prime, it means complement of set A elements in the universal set. In the universal set, but not in the set. But not in the set. So basically, that is what this means. Complement of set A elements in the universal set, but not in the set. In the universal set, but not in the set. So we have learned those things from episode 1, 2, and 3. If you really understood it very well, you understand this part. Now, let's now begin with the whole work. All right? Let's begin with the whole work. So we are going to start with the statement of De-Morgan's law. So once we are done with the statement, then we start with the first De-Morgan's law. So statement of De-Morgan's law. So 1. So we're going to start with, for any subset, let's say A and B, okay? For any subset, let's say A and B of a universal set, U, then we can say that the first law, let's begin from here. We can say that the first law, we are going to begin with the first law, right? So this is the statement. For any subset A and B of a universal set, say U, right? We have already defined that from here. Now, the first law says that if you have A union B or complement, right? If you have A union B or complement, this basically means A complement intersection B complement. So that is what it means. So this is the same as this. So you see what De-Morgan's is trying to do over here. If you use union, then the other side will be what? Intersection. When you're trying to split this, then it's going to be what? Intersection. So that is one of the main heart of De-Morgan's, is switching from union to intersection, from intersection to union. That is one of the main heart of De-Morgan. So you can see that A union B or complement is equal to A complement intersection B complement. Now, let's look at the next thing, right? The next thing is we want to look at the meaning of these things, right? The meaning of these things. But before then, let's look at the sub law under the first law. So you see, we did union and we spread it to have this, right? Now, A intersection B or complement is the same as A complement union B complement, right? So this is right here. Then the reverse is this. Beautiful. So if you have A union B or complement, it's the same as A complement intersection B complement. Alternatively, right, or similarly, if you have A intersection B or complement, then is the same as A complement union B complement. See how beautiful the De-Morgan's law is. Very, very interesting. One of the main or one of the interesting topics in algebra is De-Morgan's law, because it's just switching like that. Great. Now, let's look at the second law. The second law, basically, it's another form of switching, right? So, yeah, the second law is A intersection B complement or complement, right? And this is the same as A intersection B. So if you have A intersection into bracket A intersection B complement or complement, then this is the same as A intersection B. Because, you know, if you expand this, you're going to have, this will come and nullify this. So you're going to have B here. And then you know that A intersection A is the same as A. Remember this. So if A intersection A is the same as A, then if this comes and nullify this, then you're going to have what? A intersection B. And that is what is there. Great. So that is well understood. Now let's look at the sub law under the second law. So this is the first one under the second law, right? So the second law under the second law. So second law, we have sub. So A and B. So the second one is A minus into A minus B is equal to A intersection B, right? So if you don't see this, you will see this, right? So this right here is the same as this right here. Why? If you see A minus B is the same as A intersection B complement. Remember in episode 3 or episode 2, we talked about all these things, right? We talked about it. So I believe you are cool with it. A minus B is the same as A intersection B complement. Great. So this is the same as A intersection B. So that is the second law, A and B. A and B. Now, let's look at the meaning of these laws, right? So the meaning of the first one, right? And then the meaning of the second one. So the meaning of the laws. Meaning, right? So laws, we are going to look at the law 1, explanation to the law 1, then we come to the explanation of the law 2. So law 1. Law 1. If this basically means that not A or B, right? Not A or B means that not in A and B, not in B, right? Not in A and not in B, right? So if you see not this right here, this first law, A union B or complement is equal to A complement intersection B complement. The meaning is that not A or B, and this basically means that not in A and not in B, not in A and not in B. That is the meaning. Now we can now say that hence A union B or complement is the same as A complement intersection B complement, right? So that is the meaning of just giving out here. Not A or B means not in A and not in B, not in A and not in B. So that is what this law basically means. So let's look at the law 2. Law 2. So we say that not A and B, right, means that not in A and not in A or not in B. Hence A intersection B or complement is the same as A complement union B complement, right? So this law we see right here, that is what it means. So I wouldn't say it's law 2, but I would say law 1 sub, right? So that would be B. So I named this one 2, this one 1. So okay, so law 2, right? Good. So if that statement means that not A and B, not A and B means that not in A or not in B, right? So this we see right, you see union is combination, right? So we are saying that not in A or not in B. So that is what this particular means right here. So we continue with this. So let's say that, so this or right, or produces and, right, produces and. So it basically means that switching is the heart of De-Morgan's. Switching is the heart of De-Morgan's laws. So you can basically see that if you see or, it produces and that is what we are seeing here. Or here is producing and. So it basically tells us that De Morgan's law, the heart of De Morgan's law is switching of union to intersection. So it deals with or and or and. Great. So we're going to continue with some example, right? So we are going to verify what we have done using example, or we are going to use counter example to verify what we have done. It's interesting when you understand De Morgan's law because it's going to lead us to the 2 set and 3 set problems, right? So let's look at some verification using an example. So verification using an example, right? Or using example. So the question is, let u equals 1, 2, 3, 4, 5, 6, 7, 8. Right? So this is the universal set. Now, A is equal to 1, 2, 3, 4. Right? And B is equal to 3, 4, 5. Right? So we have the universal set to be 1 to 8. Right? And A is equal to 1 to what? 4. And also B is 3, 4, and 5. Now, the first question is, you want to find A union B. Alright? You want to find A union B. So, this is going to be very simple because we have understood episode 3. Right? Everyone here on episode 4, I believe that you have really understood episode 3. So, here, first question you want to tackle on this particular example is to find the union between A and B. So find A union B, right? So A union B here is equal to, A union B means that we are combining A and B. So the summation of A and B. So 1, 2, 3, 4, and 5. Because we have 3 and 4 in A. So we don't include it again. It becomes repetition. We are not interested in repetition of items, right? So we write 1, 2, 3, 4, 5 here. So basically A union B contains the elements 1, 2, 3, 4, 5. So that is A union B. Right. Now, let's look at the second part of the question where we are to find A complement and also B complement. So, second part of it is A complement and B complement. Right. So if you want to find A complement basically means that you want to take A, the set A, and take the whole of set A from the universal set. Right. So for instance, you are with your mom, right? And you want to have some informations, right? Basically, you go to your mom. So you take the information that you have from your mom, and the rest becomes the information that you don't have, right? So A complement is equal to we take 1, 2, 3, 4 from the universal set, and universal set is 1 to 8. So basically we are going to start from what? 5 to what? 8. So A complement is 5, 6, 7, and 8. Right, so that is A complement. We subtract A from the universal set, then we get A complement. Now, we want to find B complement, right? B complement is the same process. So we subtract B from the set, the universal set, right? So B here contains the objects 3, 4, and 5. So we take 3, 4, and 5 from the universal set. So it's going to left with 1, 2, 6, because we are taking 3, 4, and 5. So you're going to left with 1, 2, 6, 7, and 8. 1, 2, 6, 7, and 8. Right. So that is B complement. Now, the next question is, we want to find A complement intersection B complement. Great. Now the work becomes very easy, right? So we have A complement, we have B complement. We now want to find their intersection, the element that is common to these two sets. Right. So find A complement intersection B complement. Right. So A complement intersection B complement is equal to this and this. What are the common elements between these two sets? Great. So we look at this. I can see 6 here. I can see 6 here. So I have 6. I can see 7 here. I can see 7 here. So we have 7. I can see 8 here. I can see 8 here. So we have 8. Great. Great, great. So that is the common element between A complement and B complement. Right. So A complement, B complement, intersection B complement is 6, 7, and 8. That is well understood, right? Great. So now, looking at the example, we could realize that, or we can see that we have been able to verify the law, right? Because we obtained A complement intersection B complement, right? Now, let's look at something. A union B is right here. Now, let's try to find A union B or complement. So if you want to find A union B or complement, then it means that we are going to take A union B from the universal set, right? So A union B or complement is going to be, we are going to take 1, 2, 3, 4, 5 from the universal set. So 1, 2, 3, 4, 5 from the universal set is going to left with 6, 7, and 8. So we have 6, 7, and 8. Powerful, powerful. So we can see clearly from here that, remember, the first law that we stated, we said A union B or complement is the same as A complement intersection B complement. And here, we have been able to verify that. So we can see that A complement, A union B or complement have the same set as the A complement intersection B complement. Hence, A union B or complement is the same as A complement intersection B complement. And this alone has verified the law. That's the law verified. The law verified. You can see, so beautiful. Mathematics is all about numbers, and it's so beautiful if you are able to, understand the basic principles that guides the language. Right. So Now, once you have been able to verify the law, let's now move on to the next thing on the list, where we will talk about the De-Morgan's law. Now, we are going to use the diagram, right? We are going to use the Venn diagram to, demonstrate the same laws that we demonstrated algebraically, or using symbols, right? Where we use the algebraic symbols and stuff. We are going to use visual representation, or the Venn diagram, right? To, demonstrate the De-Morgan's law again. Great. So we go again. The next on the list is to demonstrate the De-Morgan's law in a Venn diagram. So we are going to begin with A union B. Right? So A union B, if you are given A union B and you want to showcase it in the Venn diagram, how do you draw that? So we say that this is our Venn diagram, right? And this is set A, this is set B. So we call it here A, we call here B, right? And this is the universal set. So mostly the universal set is what? The whole of the sets, or the whole of the environment. So this is the universal set. Now we want to find A union B. So how do you shade A union B in the diagram, right? So A union B basically means that this whole set is for A, right? That whole set is for A. So if you want to say that this whole set is for A, then it means that this is for A, right? So we can shade all of this. Now, the whole of this as well is for B. So we say that we shade this section. Okay? We shade this section. So this means that A union B covers the whole section of set A, and it also covers this whole section of what? B. So we call it A union B. That is so powerful, right? So this is senior high studies, right? So this is the representation of A union B. Now let's go to A union B complement, right? Because that is what we did in the law. So we are going to draw A union B complement in the Venn diagram. So the next illustration is A union B A union B all complement, right? So we have A here, we have B here. So we call this A, we call this B. All right. Now we want A union B all complement. So how do we get that? Now we know that complement are those elements that does not belong to A, neither do they belong to what? B. So those elements are going to revolve around the set. So A complement union B complement is basically the whole of this section, all of this section, all of this section, all of this section, all of this section. So all the section outside the set A and set B becomes your A union B all complement. Becomes your A union B all complement. So you can see that all this section, these guys, or this section, let me call them some guys, all right? We are making a project, right? These guys decided to not to be part of set A, neither would they be part of set B. So we call them complement. So if you combine these two guys, we call them A union B or complement. So the A union B or complement is this section of the diagram. Now, the next diagram is A complement and B complement. A complement and B complement. So what we are going to do is to illustrate that particular one as well. So we have this here, and we want to shade A complement and B complement, right? So this is set A, this is set B. So A and B. How do we shade A complement and B complement? So this is, as earlier said, this is set A. The whole of this set is A, right? The whole of this set is A, all right? And the whole of this set is B, right? The whole of this set is B. Now, how do we know A complement and how do we know B complement? So if you are talking about the complement of A will be this particular section. So the whole of this section is the A complement. The whole of this section is the B complement. So A complement, B complement is this. So it does not include the intersection. So A complement this, B complement is that. Don't shade the intersection. Okay? Don't shade the intersection. That is not A complement and B complement. So that is what we have right here. Now, the last work is the last illustration. I want to give it to you because now I've drawn A complement and I've drawn B complement. Now, what I want you to do is to combine A complement intersection B complement. So you look at these two illustrations, this set in particular, combine them and find A intersection B complement. Find their intersection. Where will you draw it? Do that. Great. Now, once we are done with this section of the lesson, now let's look at so with De Morgan's law for three sets, it's basically just an extension of the two sets, right? So it's like stretching the how do you call it, the distance formula when you have two points, right? And you get to the third dimension where you extend it to the z. The same thing applies to the De Morgan's law. We are just going to extend it, right? So it is an extension of the two sets, right? So for sets, let's define this. For sets A, B, and C, we can say that A union B union C or complement is the same as A complement intersection B complement intersection C complement. So as I said earlier, it is just an extension, right? It is just an extension. You can remember that in the two sets or in the De Morgan's law for two sets, we only had A union B or complement, but now we have A union B union C or complement, and now the intersection too has extended. So it is just an extension. There is nothing new in this. Now let's look at the second part of this, where we have the intersection A intersection B intersection C or complement is the same as A complement union B complement union C complement, right? So this one and this one, they are from the previous discussion we just did, and this is just an extension. So That is for 3 sets, all right? Now, once we have known this, I want us to move on to the importance of the De Morgan's law, right? So, when it comes to the importance of De Morgan's laws in algebra, it's basically very, very, very useful. Very, very, very useful. Very, very useful. So, importance of De Morgan's laws in algebra, right? So first of all, we are going to look at how it will help us, right? So first important is it helps us to simplify complex expressions, right? So it helps us to simplify complex sets of expressions, right? So from the introduction, you can remember that I said for simplifying, rewriting, and proving identities that involves sets, right? So the first importance, it helps us to simplify sets, complex sets of what expressions. The second one is it helps us to basically solve algebraic problems, right? So it helps us solve algebraic and logic problems, right? That is the second one. The third one is basically it helps us to work with complement, right? So it works with complement easily. So you can see that when you come here, this all complements, it helps us to work with the complement and it makes work so very easy. So works with complements, works with complements easily, right? Fourth important is it's suppose proofs, right? So for instance, if you have a proof, right? So it supports us to do proof writing. So support proofs in algebra. Support proofs in algebra and logic. Support proofs in algebra and logic. So these are 4 main importance of the De Morgan's law in algebra. First of all, it helps us to simplify complex set of what? Expressions. 2, it helps us to solve algebraic and logic problems. 3, it helps us to work with complements easily. 4, it helps us or support proofs in algebra and logics. So these are 4 importance that I have for you in De Morgan's law. Now, once we have been able to see or have some importance, let's look at some mistakes that you can do as a student or a beginner learning set theory. So we look at some common mistakes. So common student mistakes. Common student mistakes. 1, they normally forget. So forgetting to change union to intersection. Forgetting to change union to intersection and vice versa. Forgetting to change union to intersection and vice versa. That is the first one. That is a mistake that a student can make, or you as a beginner learning set theory. Two, they normally take complement, right? Taking complements incorrectly. Don't take complements incorrectly, right? So that is the second one. Third one, ignoring the universal set. Ignoring the universal set. So these are some few common mistakes that you as a beginner learning set theory can do, right? So first of all, don't forget to change your union to intersection when you are doing the opposite, right? So for instance, the first law, A union B all complement, right? When you are moving to the other side, it becomes intersection. It becomes intersection. And students normally forget to change the union to intersection. So don't be a victim. When you are changing from this to this, it becomes intersection. When you are here and you are coming here, it becomes union. So if you have A intersection B all complement, when you are coming to union, it becomes A complement union B complement. You see the thing? So you don't confuse them, or you don't forget to change this to this when you are going to this way. Now, that is the mistakes you can commit. So that is the end of the lesson, but I won't leave you that way. I want to give you some quick practice problem for you to try your hands on. So, quick practice problem. Quick practice problem. So, quick practice, right? So the problem is, if question 1, if the universal set U is equal to 1, 2, 3, 4, 5, and 6, now A is equal to 1, 3, and 5. This is the question, right? If U is equal to the set 1, 2, 3, 4, 5, and 6, and A is equal to the set 1, 3, and 5, I want you to find this for me. Find A complement, all complement. You find the A complement and all complements, right? So A complement, all complement. 2. So that is 1 under the same question. 2. Find or verify A intersection B all complement equals A complement union B complement. So you verify this and then you find this. So as we did from the verification, you do for all, then you come and check if these things hold. If it doesn't hold, it means you have problem with your workings. So the verification, you have to make sure that A intersection B all complement is the same as A complement union B complement. And then also you have to find A complement all complement. Provide your answer at the comment section. I'll be checking up on that. So that is a quick practice for you. That is the end of this lesson, right? But let me give you a summary or conclusion to this episode 4. So basically in this episode, we studied the De-Morgan's law, which describes how complements interact with union and intersection, right? And then we used diagram, right? So we used the Venn diagrams we visually verified that is the complement of a union becomes the intersection of complement, and the complement of intersection becomes the union of complement. We have verified that. Now, these laws are very, 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 very important in algebra, okay? These laws are very, very, very important in algebra because, one, they will help us to, simplify set expressions as we stated in the important section. It will help us to simplify set expressions, very complex ones, to become very simple, right? And it will help us to solve algebraic problems and logic problems correctly, right? It helps in, it involves, or it will help us to, take complement correctly as well. So with this understanding that we have, I believe that we are now ready, right? We are so much ready to apply union, intersection, and complement to practice or practical situations. So the practical situation is where we will be coming, especially when we talk about the 2-set problem, the 3-set problems, right? So in episode 5, we are going to talk about the 2-set problem, where union, we are going to use the Venn diagram and the set formulas to, solve real life and examination type questions. Very interesting, right? So expect episode 5 in the next day. Bye-bye.